Okay, this is the beginning of our power series. Okay, guys, what's a power series? Geometric is an example of one. A power series, well, okay, you guys, a power series, what's a series? It's a sum. And you know what it is? It's the sum of powers of x. Okay, we know of one power series, we know of the geometric one. There it is. What does it converge to? Well, it only converges when x is a certain value. Hey, Grant, you remember what that is? Do you see that this is geometric? What's A? A is equal to 1. What's R? No, x. How do you find R? It is the number you multiply by to get to the next term. So I'm going to multiply by x here, and I'm going to multiply by x again. That's a geometric series. Okay, and then what's the sum equal to? A over 1 minus R. To get a 5 on the exam, you have to know that because you're going to see many geometric series on the exam on the multiple choice. And probably on the free response. Yes. So this is equal to what, Grant? What's A? 1 over 1 minus x. But it doesn't converge for every single value. Matt, what does it converge for? Converges when the absolute value is less than 1. So R is between 1 and negative 1. Now, anytime you have a geometric series, the interval of convergence is always going to be that 1. We're going to do some things to that, okay? Not today so much, Trevor, such that you're going to have to check endpoints some of the time. It never hurts you to check endpoints all the time. But if you know it's geometric, they give you a power series, you say, oh, it's geometric, then I don't have to check the endpoints. But I have to be careful, because sometimes when I do some operations with it, I do have to do that. Okay, so this function here is equal to 1 over 1 minus x. Do you want me to graph that again? Remember, the 1 over 1 minus x looks like, well, it's 1 over x. It's just shifted. No, it's shifted. You have an asymptote here, so it looks like this. And this only converges from... Oh, you're right. It's negative. Read it. Okay, so what does it look like? Maybe I should. What's it going to look like? I'm confused. Like that? That's what I'm saying. I'm confused. You want to come up here and draw it? I can't. I don't know what you're saying. Well, when x is 0, this is 1. When x gets large, maybe I better graph it. I could do is factor out a negative. Yes, there is a, if I factor out a negative 1, it's what? X minus 1. Is that right? You're right. Where's an asymptote at 1? Oh, I don't want to do that. Okay, so this is going to come along. I have no idea what this is going to look like. I mean, what? I probably better grab it. But what does this do? Well, it depends on how many terms you have. The more, now only at negative 1, it only converges in here, so it's going to do crazy things. It could do that. It could go down. Well, no, because I could go x to the third. I could do an odd power, in which case then it's going to come in like this. Yeah, but that was an even power. If it's an odd power, it'll be down here. Okay, it's the only place it converges. Okay, this is a family. This is like like a parent function. Remember parent functions. What we're going to do, we would like to get some more power series. And we don't know any way to find a power series, Sam, except to work with this one family. Taylor found other families out there. He found e to the x and the sine of x. So I can manipulate this function, 1 over 1 minus x, to get a whole bunch of other things. And this is what's cool. And you're going to see this on the exam, both free response and multiple choice. So we know that this is true. We could graph that on our calculator. So let's go to the next page. I want to do 1 over 1 plus x squared. So first I'm going to write out 1 plus x squared. You have to memorize this, plus x cubed plus x to the n is equal to 1 over 1 minus x. Would have preferred x plus 1 or something, but that's what it is. I want to make this look like this. It's a relative. That's the hard part. It's 1 over 1 plus x squared is the same as this. Once I show you the trick, you'll see what to do with it. Okay, if you're not paying attention, you're going to be in trouble. Do you see that this function here is the same as the original function? Now it kind of looks like 1 over 1 minus x, doesn't it? But in place of the x, what should I put there? A negative x squared. So guess what? I put it in for this x, and this x, and this x. I don't have to do anything fancy. So it's 1 plus my new x plus x squared plus x cubed plus, I ran out of space, let's do x to the 4th plus dot, 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 n power, because they're going to ask you for the nth term. Now, what am I going to put in there for x now? Negative x squared. You see how I'm substituting that? I'm using a formula I already have and saying, well, these are related. I had to make this look like 1 over 1 minus x or something. It's called a squiggle. So it's minus this thing. That's my new x. Okay? So we're going to put it in here. And this is minus x squared. This is minus x squared. And some of these are tricky to do. So do them in the order in which they were assigned in the book. Because we're going to build on it. Okay, Ori, is that okay? Well, you should turn your page. Because this is what we're doing. And what does that come out to be? There's example 1. Oh, is this at the bottom page? So what is this? 1 minus x squared. What? Plus x to the 4th. We'll find where we are. Minus x to the 6th plus x to the 4th. Whoops. You're right. That's 8. I forgot to multiply the 2 and 4. And then, because what are you putting in here? You're not putting in x squared. You're putting in minus x squared. Say that again. This is negative 1x squared. That's going to be cubing it. What's negative 1 cubed? Negative. I get minus x squared times minus x squared times minus x squared. That's a negative. It's not, this is not inside the x. This is a negative 1 times x squared. So it doesn't cancel out. It is in parentheses, but when I cube it, it's still going to stay negative, isn't it? If these were all even powers, you're right, everything would become positive. But it doesn't. So it's what? It's negative. Let's do the nth term. Okay? It doesn't make the negative go away. It's 1 minus. Okay, Grant? So it's going to be this, which is the same as a negative 1 to the nth times x to the squared to the nth using properties of exponents. Is this going to be positive or negative, this negative 1 to the n? It's going to alternate. Depends on n, doesn't it? If n is even, it'll be positive. N is odd, that'll be negative. So it's negative 1 to the n, x to the what? 2n. whole bunch of relatives to the 1 over 1 minus x. Tons of relatives. Aunts, uncles, cousins, sisters, brothers, a whole bunch of stuff. You can do derivatives, you can do integrals, and you can relate them. Guess what? What's true about the radius of conversion here? It's still, x squared is still going to be less than 1. That's your r value, isn't it? What's your r value? R equals what? What am I multiplying this by? X what? Squared, negative x squared. Okay? What's going to be true about x? X is going to be between 1 and negative 1. We just did that yesterday. Okay, ready? Let's try this one. A little trickier. I need to make it look like 1 over 1 minus x. Or you should do the problem so you're not going to know how to do it if you don't. I only have, like, what, 2 examples? We can do problem right out of the homework. You just have to see what the relationship is. That's all. And they're going to be, this is going to be on the multiple choice, and it's going to be on the free response. Okay, first, it doesn't look like 1 over 1 minus x, does it? But how about if I did this? What if I did this? 2 plus x. Getting a little bit better, because it has the 1 first, so I'll put the constant first. Can I factor out a 2? Yes, take a 2 out, and I'm left with 1 plus x over 2. Because I need to make it look like this. Because once I make it look like this one that I know, then I can just substitute it into the formula, and I'll get the answer. So this is what? 1 over 2, and it's 1, and I have to have a minus sign next, and this is negative x over 2. See the trick? It's just a trick. Okay, so I have to remember what 1 over 1 minus x is. So I'm going to write it out again. 1 over 1 minus x. 1 plus x. I want to make it minus, but it's still that minus there. But it's not. It's x squared plus x cubed plus x to the 4th plus, and it's plus x to the n. You have to be able to do the nth term as you've already seen. Okay, so what am I going to put in now for my x? I'm going to put this thing in. It's a trick. It's a more of a distant relative, isn't it? Still related. It's a distant relative. Can I take any function and make it look like 1 over 1 minus x? Can I make the sine function look like that? No. So sine isn't geometric. It has to be geometric, right? But there's a whole bunch of relatives. Okay, so let's do this. So it's, now this is really 1 half times 1 over 1 minus x over 2. Is that okay? Pull the 1 half out. Is that okay, Grant? If you don't tell me now, you're going to get lost. I don't want you to get lost because it's complicated. So it's okay to be lost? No, it's not okay. So it's 1 half. Now, what are you going to put in for my x's here? Okay, so it's 1 plus a negative x over 2. Sometimes you have to simplify, sometimes you don't. It just depends on the context of the question. Especially if it's multiple choice, you will have to simplify. Then what am I going to put in for x squared? Negative x over 2 squared. I'm going to take this and put it in for all these x's. Plus, I just left the 1 half out there because it's just a constant. And it's negative x over 2 to the what power? Third. Plus negative x over 2 to the what power? Fourth. Plus, and then it's negative x over 2 to the nth power. Depending on what you're doing, if you're going to do the ratio test, you'll have to simplify that. If you're not going to do the ratio test, you probably can just leave it. They will ask you for the nth term. And that's good enough, but we're going to simplify it because I have to match it on the test. So I've got to be able to match it. And I'm going to use it for the next example. So it's what? I still have that 1 half there. So it's 1 what? minus x over 2 plus, hey guys, what's the next one? X squared over 4. What's the next one? Minus x cubed over 8. Do you see the geometric sequence there? Series there? Plus, what's this going to be? X to the 4th over 16. Well, I'd like to fix that. It's a negative 1 to the what power? N. Then it's times x to the n over what? 2 to the n. Now you can do the ratio test if you require. What's r? That's right. How are you going from here to here? R is equal to negative x over 2. So it's geometric. Negative x over 2, the absolute value of that, must be what, Eric? Less than 1. Can't miss it. It's one bit, you're going to miss the whole thing. Matt, put your phone down, please. Okay. How do we do that? We just did this yesterday. You can rewrite this if you, those of you who want me to, I will. I can do that with multiplication and absolute value. So what am I going to get, Ori? Eric, what am I going to get? Absolute value of x over 2, because this is just positive 1, is less than 1. Solve for x. Absolute value of x is less than 2. So my radius of convergence is, no, that's interval. Radius is this number right there. It's 2. The interval says I'm going to center at 0, and I'm going to go 2 units to the right and 2 units to the left. Am I ever going to include the endpoints? No, it's geometric. Could you do the ratio test and prove it? Yes, you could do that. But why do it? Pardon? Oh, you would substitute your endpoints, 2, back into right in here. And you'll see that you get negative 1 to the n times 2 to the n over 2 to the n. It doesn't hurt to do it. And what happens to these guys? And so I have the summation of negative 1 to the n, and we already know that that diverges. The limit of that sequence is not 0. Some of you make these things too hard. Always look for the limit of your sequence first. And then what about the summation of 1 to the n? There's no limit to that one. What's this limit? The limit of 1 as n goes to infinity is 1. But because that's not 0, it diverges. Okay, so the endpoints diverge. Won't hurt you if you can't remember. Oh yeah, it's geometric. I don't have to look at the endpoints unless I do some crazy things to it, which I could. And is that it? Oh, there's one more. Okay. Oh yes, we're going to take our answer here, and again, this is just using a trick. And I may have it on another slide, or let me take a picture of this. Hang on. This is my series right here. So I'm just going to take a little picture and try. Well, no. There we go. I don't know why it does these crazy things. I don't like that. Oh, I made a picture. I don't know where it went. There it is. Is that it? You know what? Let's just work on the same page. Okay, I'll just rewrite the problem. It's no big deal. It says find a power series. These are all power series because they're sums of powers. Now remember, I just found out what this one was. Right? That was 1/2. 1 minus, what, x over 2 plus x squared over 4 minus x cubed over 8, etc. How is this related to this one? It's so easy. Isn't this x cubed? It's going to drive you nuts when you see this. Over 1 times 1 over x plus 2. all you do is multiply this new series, or the old series we just found, by x cubed. So multiply it by x cubed. You could distribute it. That's the power series. If you grab x cubed over x plus 2 in one function and graph this thing in another function, you will get the same thing, but where? Where's the interval of convergence? It's from negative 2 to positive 2. It's only going to be the same there. It won't be the same everywhere. And you could simplify that if you wanted to. I don't know. It would depend. If you were matching, you might have to simplify it. This would be 1/2. Then it would be x cubed minus x to the 4th over 2 plus x to the 5th over 4 minus x to the 6th over 8, etc. And that was a negative 1 to the n x over 2. It was that, right? So let's multiply that out. That times x cubed is a negative 1 to the n, x cubed times x to the n over 2 to the n. What does this simplify to give you? What do you have to do? N plus 3. You can just reverse it, which is fine. Okay, so you really need to do the problems on this assignment. We can look at it. We can do the first one together, but sometimes it's just really hard to see how it relates, what the relationship is to the geometric family. But they are. So this is section 8.6, and it's really an important section. 8.7, we're not going to do much with it out of the book except practicing to get Taylor polynomials. Because you know what? Do you think e to the x is related to this guy? No. Well, I did number 3, and I don't know what I assigned. What did I assign? Well, I can look. They're not easy. One, 2, and 3. I did 3. I've already done that. And then the odds. So how are you going to do number 5? So this is 8.6, number 5. If you need more practice with the ratio test, you need to do the assignments. See, the problem is trying to figure out what to do. Okay, Zach? Zach? You could. How are you going to do this one? Okay, guys, I need to make it look like this, right? Okay. Okay, guys, give you a second here. I want to make it look like that. Ori says factor 3 out. Now, if I factor out a 3, I'm left with 1 minus what? X over 3. Once you see this, it's easy. So now I want to take out what number? Alex? 2/3. There you go. Okay. Well, you've got to, what's this? 1 plus x squared plus x cubed. Interestingly enough, e, no, it's plus. This is 1 minus x. Those are all pluses because that's what it is. Remember, it was s equals a over 1 minus r. R was x and a was 1. Those, remember, we started here and we got to this. Geometric. No, that was, the alternating one was over here. That alternated, and we can go back further. That's the one that alternated. No imaginaries. Okay, guys, you need to be working on your math. Okay, Good. How am I gonna? What am I gonna do now? Eric, what am I gonna do? What about the 2/3? So it's 1 plus. No, it's just x over 3 plus x over 3 plus x over 3. Don't forget the nth term. I looked at last year's exams, and a number of people forgot to do the nth term. And that would cost me a point. Now they'll give you, on something like this, they'll give you a point if most of the terms are correct. If I forgot the fourth here, they would give me 1 point instead of 2 points. That's all. Etc. I forgot the fourth. And by the way, don't give more terms than they ask for. If they ask for 3, do 3. Mike. Homework on the assignment sheet. That's old, out of the old book. So it's not that much, but you really need to practice with it. Some are tricky. Number 9, I challenge you to do number 9. There we are. What do you want me to do with it? Square? It's done. I mean, you can make that x squared over 9, x cubed over 27. You can do it. Oh, did they ask for the radius of convergence? Yes, it does. It asks for the interval of convergence. So what's r? Sometimes I forget about doing that. X is equal, sorry. R is equal to x over 3. So the absolute value of x over 3 is less than 1. So the absolute value of x is less than what? 3. Now you guys have a quiz on this next week. R is equal to 3. They ask for the interval of convergence, so it's -3 to +3. It's geometric, so no need. Now what they've done, also on the exam, okay, Michael, Matt, I've noticed, I know we're close to winter break. We're not there, though. I've noticed on the exam, guys, that they will give you a series that doesn't look geometric, and in the course of manipulating it, you get a geometric series. You need to recognize when that happens. That's not always easy to do. Okay? So you have time to work. Work time. 7, yes. Sure. They don't care if you do interval notation or inequality notation. Number 7. See, they're not easy. Eric, how are you going to do this one? Eric, Ori, how are we going to do this one? I have to make it look like this. So we take out an x. I'm left with this. Okay? Alex, question? What are you going to do with this one now? So it's x over 9. Then it's 1 plus x squared over what? 9. It's still not right. So it's equal to x over 9. You'll just take that x and multiply by your answer. It's 1 over 1 minus a negative x squared over 9. What's r? It's that. That's r. You guys can't hear. Michael? It's x squared over 9. Oh, yeah. Then you get this series. Guys, if you're going to have your conversation, the door's over there, okay? I don't care. But this is the series, okay? And you take whatever that series and multiply it by x over 9. So it'll be x to something. Remember when I just did that back here? Okay. Yeah, That's always going to be r, once you get it into the right form. Yes, we do. We have to find the series. Because it asks you to find the series. Yeah, well, we haven't finished. We got it set to go. So let me write out the geometric series 1 over 1 minus x again. Okay, there it is. So it's going to be x over 9 times this series. Now, it's 1 plus x. What's x? What's x here? Negative x squared over 9. That's to the first power. Plus. And now I'm going to do negative x squared over 9 to the what power? Second. Plus. Minus, what's going to happen to this? It's going to alternate, isn't it? To the what? Third. Now you could have said this was x over 3 quantity squared. You could have written it that way. It doesn't matter, though. It's the same thing. Etc. And it's negative x squared over, whoops, it's negative x squared over 9 to the nth power. That's done. Well, that's a series. I mean, you could simplify these. That's minus x to the 4th over 9 squared. You could do that. Pardon? I can't find it, and I'm using, well, I could, I suppose. It was hard. Yeah, I mean, you could do that, but you still have to write it out. Now, if r is equal to negative x squared over 9, what about your radius of convergence? So x squared over 9 is less than 1. So x squared is less than 9. No, because these are all geometric. You do not need to check the endpoints because they're all geometric. But the sine of x and cosine of x are not geometric. E to the x is not geometric. So we'll have to find out after break another way to find those power series. So how do you know what to do either? You recognize it looks like 1 over 1 minus x. It doesn't, but no, if it's not that, then you're going to have to learn another way to do it. This kind of looks like that. It's in the right form. But e to the x doesn't look like that at all. And tomorrow we're going to use derivatives and integrals to find more relatives. Yes. We can't have x squared there. You need to be working on your math. That's good. You better do it. Because when you're on the exam, you need to do it like now. And you can sit there and say you understand it, but I've looked at last year's exams. I know they did well on the test when we tested, but I've looked at them and they're not good on this problem. Not the ones I've looked at. Yeah. So don't assume anything. What? I'll have to slide it. It's right there. So it's negative 1 to the n, x to the 2n, and 9 to the n. Yes.